maybe first, this is what means my terminology. For start, I consider dynamical system on compact space, and dynamical system generated by continuous movement, space X into itself. And here I use standard behavior are but some different. Standard notion is omega limit set for describing of asymptotic behavior trajectory in the dynamical system. We have
what about using this?
maybe it will be more easy.
Maybe return was slide just because some partitions.
And I used instead name notion omega limit set because each of omega limit set usually is omega limit set for many other trajectory I use for omega limit set more short, not term omega attractor. And the set trajectory which attracted by this omega attractor is usually named called as basin of omega attractor. We have basin of omega attractor is subset of phase space which attracted by this omega attractor.
Да, то только там должно быть не А от аргумента X, а А с индексом X. Если следовать. Ну, это так, беспредельно.
And maybe the most of the result present in this talk is all result from 60th year of past century. But I will try to speak about a result which is with known. More, this old result was published. Also, most of these results will translated into English in the same time. For example, starting 61 and first 61 is American Mathematical Society start translated theory of journal Doppler Academy now and that was starting in 1960. And well known, I think, here, if dynamical system has so-called smell horseshoe, then I think has very many omega attractors, different omega attractors. For example, we have phase space interval, and for example, map has cycle of period not equal to power k with all k. Then we have so-called one-dimension horseshoe, or I use term lambda sham. In this case, there exists, that means there are two disjoint intervals, and for each we have such increase. And I'm going to talk about dynamical system on omega attractors, properties of all omega attractors as subset in space of 2 power x. Then also properties of basin of such omega attractors. Each omega attractor, dynamical system on each omega attractor has such property. If we, for example, have any open relativity to attractor subset, then image of...
So this is general topological dynamics, right? This is just pre-compartment.
Yes, this is for any compound.
Yeah, that's general topological dynamics.
Yes, this is general topology. Different such property. From this property, we obtain that if omega attractor is finite set, then this is cycle. If omega attractor is infinite, then any isolated point cannot be a periodic point, for example. This property incompressibility of dynamical system now omega attractor is also not only necessary but also sufficient if we have, for example, space, our space, and we have any, for example, subset such that this subset has no open subset in X, and we have such property in dynamical system, for example, given here, and take such property. In this case, we continue to extend the dynamical system on some neighborhood of S, such that for dynamical system, for this subset of X, this set S will be omega limit, omega attractor. For example, if you consider one-dimensional method standard, for example, the simplest, for example, for such dynamical system, if you have only, for example, only situation, this dynamical system has also cycle, no, for example, have infinite dimensions, and then we have such situation. If any subset S with such property is omega attractor, for example. What is, for example, more general situation? What is here, for example, main. It depends on the behavior of dynamical system in neighborhood of omega attractor. It takes sense to book, for example, such three possibilities, and for example, you have, for example, such situation. If, for example, our space is interval, and so has cycle of such period, then exists maximal omega attractor containing cycle. In this case, we have such situation. This is or Tangle set or set of finite main interval for cycle of interval period. For example, this I can. For example, we have. I take, for example, simplest stem map. For example, the interval E01. Here, for example, this example, we have only one maximal omega attractor, and this is well known. This is all our space interval, and we have maximal and we can see it's many contour set as omega rings, omega attractors. This is all. For example, on this interval, we have many contour set, continuum many, and here this is row is means including, and this is standard situation for this is standard situation if exists such maximal omega attractor, and such omega attractor exists always, we have cycle of period different from 2 power e.
So is this a symbolic picture or what? What это символическая картинка или реальная? Что это за картинка?
Here, no,
На слайде.
we have, for example, this is interval. For example, this interval. We must see, you see here, any continuum many counterset here. This is inside of interval. We have many omega
Yeah, those are all the marks.
joint, for example, if or including if and this we have maximal also.
Those are minimal.
Down we have minimal cycle.
Okay.
And if, for example, we consider any chain starting, for example, in the bigger and finish to small, and this and we contain full chain, not another omega attractor. This chain will be similar to rational number. Because between, if you have, for example, this is cycle. Here, this is, in this case, for example, this is interval. And we have, if we have, this is contact set, and also this is bigger, but between any two, for example, if we have such situation, such between this exists.
Right. Do you think?
Yes.
I think such a chain would be uncountable. Я думаю, что она не счетная.
Yes.
Счетная или не счетная?
Contain shown many.
А я думаю, что она не счетная такая.
Нет.
Максимально.
No. Locally счетная. Here, but if we this change, if we consider, for example, space or here, this is change will be similar right side element of counter set. We have, if, for example, situation such, for example, we have this standard counter set, and this change here, we use metric Hausdorff for graph. For this omega attractor. Then we have, because this is locally maximal set, exists interval.
You only consider locally maximal set.
Yes.
You only consider locally
maximal.
Yes. Okay.
And
that is
if we
okay, I understand. But if you take any invariant set, it's an omega attractor for itself.
If we consider this set, if I will consider this set in here, yes, this set is denser in space of all, not only locally, but all, also more, also set of cycle will be denser in space of all omega attractors. In metric Hausdorff. about basin of omega attractor. This is standard terminology from descriptive theory of Z, F sigma Z, Z delta sigma, and if you use such terminology for describing of basin of attractor, we can propose, for example, the following. As a rule, upper descriptive decremental estimated for dynamical systems obtained relativity easy, but usually it's very difficult to prove that those upper estimates can be reached. And for any, not interval, for any space X exists such estimate. If omega factor is maximal, then basin is always the delta Z. That means basin can be obtained as intersection of containable many open sets, for example. If we have locally maximal omega, then basin is N. If we have, for example, non-isolated omega factor, then basin of such omega factor is F sigma delta. This is upper estimate, but this estimated is exact. And reached even in the situation when our phase space is interval. Maybe we have such situation. This is more or less easy we obtain, but it is sufficiently not simply, but we have such situation. For any non-isolated omega attractor containing a cycle, basin is the set of third class in varied classification. Here present such condition, for example, containing cycle. I think this is remain is true, and without this proposition, but such proof for this variant of I don't know. From this result, we follow from viewpoint of descriptive theory of set, one-dimensional dynamical system just is as complex dynamical system on arbitrary space, compact space, for example. It is possible to propose some question about this I said clearly, and also, for example, if you have general general compact space, what will be true or not proposition similar to this.
So our answer is known for symbolic system. Покажите какой-нибудь слайд.
This?
Да. Значит, ведущий случай, очевидно, это символическая система. Ведущий случай – это символическая система. Просто сдвиг односторонний, потому что у вас возникает там подкова. Для подковы это верно? Эти утверждения?
I don't know. This is my former student 40 years ago considered dynamical system where Anatoly Borisovich was as referee. And my student considered compact manifold and system and also, but when we have расширение во всех направлениях. For example, similar if you have, for example, manifold cycle and we have such dynamical system on the for example. And in this case, many results from one-dimensional map is sufficiently easy, possibly to continue for more general text. About properties of family of all attractor I already here, and if we, for example, consider such situation, that exists such statement. Here, this is family of omega attractor. This is family of logarithmic omega attractor, and here, for example, family of cycle. But take such statement is true. Each is from this subset. If density in bigger subset of space of closed set. And for some, I can show, for example, such property of one-dimensional dynamical system. If we have dynamical system on interval, we have such situation. Set of all omega limit set. We have this is set if closed. Also, in this is we have in phase space, and this is and this But this is property only for one-dimensional map. For example, for one-dimensional dynamical system. If, for example, consider even in plane, for example, such dynamical system in polar coordinates, for example, 0, and for example, Scotch is we have, for example, inside this free space, we have, for this, we have cycle as omega limit z, and but in cycle on boundary we have, and when sign is 0, you obtain here fixed point. So we have not such statement for this example. Also this statement is not true for this dynamical system, because for x we have all space without this separateness, for example, and here we have what means the set of all omega attractors. Here will be image interval, for example, 0, 1, without this point. This is in space. In this space will be image of continuous image from this interval without this point. And for finishing, I propose a small fantasy. What work our brain, it's now many works and many situations in different position and different direction. And such set of omega attractors, it is possibly used for control of work of system or similar work of our brain. Because, for example, we have here, for example, we have omega attractor. But each this omega attractor is locally, is repeller. But if we look for all space, this is settled, not repeller. This is set. Это будут седла. And we have many homoclinic and heteroclinic connecting this omega attractors. Maybe 10 years ago, for example, Rabinovich and Sosa proposed such variant for explanation what can work our, for example, brain. They propose use of, it is possibly used not only, for example, periodic for more complicated set, but use also certain points. We have such, but here they said about multi-dimensional. But it's more easy, potentially easy situation with such rich possibilities. This one-dimensional. Here I simple picture. If, for example, we have, for example, we have such 10 left. Yes. And I can propose to look at this. Situation. We have used globally maximal set only cycles, for example, for here, or also control set. It is possibly used end, but more easy used for such possibility to use only cycles, because cycles we have contain many. And if, for example, I propose, for example, such have try to see such situation. If anybody to ask, what do you know? Somebody, and this is we have in our. It is possible to transform our. For here we have the old cycle repair, but very easy to transform this each cycle into attractive cycle. It is very easy to do. For example,
not each, just one.
To do one cycle, we have very easy to impulse such impulse use. And we have in this case with such map. If we know if any signals from outside, then we have random walking on our brain, for example, and we have from outside some signal. It is possible to transform our original map in such way. If we have obtained many cycles, we use, for example, more complicated transformation, and we, for example, say about temporary attractor in time interval. We have any another signal from outside. We obtain similar another possibility to change, and it is maybe it takes this from it's very, very easy, very good path. And this is standard situation for one-dimensional map. It's general situation also. Thank you.
Questions?
Я по-русски, наверное, спрошу.
Хорошо.
Александр Николаевич, как вы относитесь к теории Фейгенбаума, Шарковского и Магнитского, которую вот последние годы пропагандирует Магнитский?
About this I не говорил. Я здесь были 5 лет назад, приехали были. Нет, не сюда приехали, они приехали потом. Но я поехал в Нижний Новгород на столетие Боголюбова. Боголюбова. Там были представители как раз из Москвы, которые вот мне сказали, что есть такой товарищ.
Магнитский.
Да. Вот. Я посмотрел, да, действительно, и даже потом увидел книжку.
Ну а как вы относитесь? Ну, вот как вы относитесь, значит, к новому сценарию перехода к хаосу, значит, который пропагандирует Магнитский? Насколько это лучше классического, насколько это верно?
Ну, богатая фантазия, может быть, Нет, если всерьез, то, так. Серьезно относиться не могу, что я могу сказать.
Понятно. Но они существенно используют ваши результаты там.
Более нет. Вот они что-то сделали, с моей точки зрения, хорошее. У него, у Магнитского, там есть люди, которые могут считать. И они действительно для конкретных задач, там, я не знаю, гидродинамики, насколько электродинамики, вот действительно проводили большой счет. И довольно точный. И там они действительно, и как они там это увидели, но на самом деле вот, меняли какой-то там или реле, или Рейнольдса параметр, и действительно из очень сложной этой самой траектории все-таки извлекли. Действительно там, меняя параметр, вот, я не знаю, в какую сторону писать, вот там видны цикл периода и меняя чуть-чуть параметры, или не наоборот там двигались. Вот действительно сложно этот год программа извлекала, и действительно можно увидеть. Вот это я действительно, очень действительно думаю, что очень ценная работа.
А вот в смысле вот этой теории, значит, Фейгенбаума, Шарковского и других, тут, конечно, вопрос, да? Понятно. Спасибо.
Other questions? Okay, let us thank the speaker again.